I'm going to define a term for you. It's called entropy. Guys, suppose you have a glass in your hand. Let's say you have a glass of wine, red wine, which is a disaster when it falls. And the red wine falls on the floor, the glass. The glass is going to shatter too many pieces. We say in this process, the entropy is increased. What is entropy? Entropy means randomness. It means chaos. If you go from one to many, we say the chaos is increased. You had one cup, now you have many pieces of broken glasses. So that's the definition of entropy. We know, I'm going to give you an example. Guys, think of Big Bang. Before Big Bang, there is one, there is unity. And then after Big Bang, there are many pieces, many stars and many planets produced. So if we say in this process, chaos is increased, randomness is increased, entropy is increased. And first law of thermodynamics talks about energy. Energy can never be created and destroyed. Then second law of thermodynamics is saying that when things happen spontaneously, like when a glass falls down and breaks to pieces, they are favored. Big Bang is favored. Why? Entropy is increasing, chaos is increasing. So things which happen in our universe favor entropy. One of the things that happen in our universe is going to increase the chaos. Order becomes chaotic. One becoming many. If one is becoming many, we say entropy is increased, or change of entropy is positive. And in this part of the chapter, we want to study if we think of a chemical reaction, is it going to happen or not? When we want to see whether a reaction is going to happen or not, we have to see, is it going into the direction of chaos or not? Is it going into direction of randomness? Is it going into direction of increasing numbers? Then that is favored in our universe. Also, thermodynamic laws say that any system which is losing energy, when delta H is negative, and we remember delta H is called enthalpy change. If enthalpy change is negative, that reaction is favored. So anything which happens in our universe is toward losing energy and becoming more chaotic, increasing the randomness, decreasing the order. That's what thermodynamics says. Guys, if in Shasta Dam, water is pouring from behind the dam, from the dam into the river, that happens spontaneously. Why? Because we are losing energy. Water behind Shasta Dam and in river, they have different amount of energy. There is higher energy at higher elevation of dam. There is lower energy at the elevation of river. That's why that happens spontaneously. And Big Bang happened spontaneously. Why? One is becoming many, like breaking a glass to many pieces. So if you want to understand whether a chemical reaction or any process in our universe is going to happen or not, we have to look at two factors. Is chaos increasing and energy decreasing? You say, yes, that's spontaneous. If that's not the case, reaction is not going to happen by itself. Spontaneity, by our definition, means something which happens without use of energy. See, when you open the channels in Shasta Dam, water pours from dam to river spontaneously. You don't need to use energy. But the reverse is going to need energy. If you want to take the water back from river to the dam, you have to use a pump and you have to use energy. So reversing a spontaneous system needs energy. Okay. Yes, a non-spontaneous system is a system which is losing chaos and increasing its energy. That system is non-spontaneous. It's not going to happen by itself. You have to use force. Are you with me so far? Thank you, Kerry. So next, if I want to judge, if I want to decide whether a reaction is going to happen spontaneously or not, I have to combine these factors. One factor is change of enthalpy, which means change of energy content. The other factor is change of order. Temperature matters as well. This is absolute temperature. Sorry. So we are going to call this delta G. It's a new term, which we call it Gibbs free energy, is equal to changes of enthalpy, changes of energy, minus absolute temperature times changes of entropy. If we calculate this and delta G is negative, process is going to be spontaneous. We can do this for chemical reactions. We're going to show you how to calculate delta H and T delta S. Then you can calculate delta G. If delta G is positive, reaction is non-spontaneous. Reaction is not going to happen by its own. It's like water going from river, jumping from river back to Shasta Dam. It's not going to happen by itself. You have to use energy. And if we calculated this and delta G is 0, that means reaction is going to be an equilibrium. What does it mean to be an equilibrium? It means reaction goes both ways. Some of it stays as reactant, some of it reacts, converts to product. You always have a mixture of reactant and product. That's what equilibrium means. And I'm going to elaborate on equilibrium pretty soon. But just for now, imagine a reaction which has a mixture of reactant and product. It never goes to completion. And we will deal with that issue later on this chapter. All right. You may wonder, how do you calculate delta G? Let's do that. The standard condition means at a temperature of 25 degrees Celsius. The standard condition also means at 1 atmosphere, and we show standard. This is the meaning of standard condition. You put a dagger, not here. Not means standard condition. Is the reaction, is this reaction spontaneous or not? We have already calculated delta G for you. Is this reaction spontaneous or not? Delta G is negative. What did we say about negative delta G?
It's spontaneous.
Absolutely. Thank you. Good job. So yes, so this reaction is spontaneous. Thank you, Hillary. Good to see you. Victoria, have you studied Gibbs free energy, enthalpy, and entropy in physics yet?
No, not yet.
Okay, you will. That's a very important, significant part of the physics. You will get there soon. How about this reaction? Reaction of carbon with hydrogen forming ethylene or ethane.
Yes.
Absolutely, thank you, Kerry. Larger than 0 is positive. It's non-spontaneous. And you might wonder, how do you calculate delta G? Where is delta G coming from? Well, how about if I give you these values? Can you now calculate delta G? Do you remember the formula of delta G? It was delta H minus T delta S, right? So if you want you to answer a question like that, we have to give you delta H and delta S. So delta G under the standard condition is change of enthalpy under the standard condition minus T times delta S under the standard condition. So if you want to calculate delta H is in kilojoule. Look at the unit here is joule. Obviously, we have to convert one into another, so I can plug it in to calculate delta G in that unit. So can I write, let's see how this looks to you. Delta G is delta H, which is negative 92.2 kilojoule times temperature. Remember, we said the standard temperature is 25 degrees Celsius. We also said T is absolute temperature. So you have 273 plus 25 degrees Celsius, you get 298. That's Kelvin. That's how you calculate Kelvin. You write 273 plus degree of Celsius. That was how you calculate Kelvin, right? So I write Kelvin temperature times, how can I convert joule to kilojoule? Can I divide this by 1,000? For joule to be kilojoule, where is this negative coming from? Right here. And plugging these numbers, you get a negative value for delta G. So what is the meaning of negative delta G? Reaction is spontaneous. Go ahead and ask a question. If this doesn't make sense, please go ahead and ask a question, please.
So, I'm just trying to wrap my head around this. Is the change in, what does change in G stand for again?
What's the meaning of delta G?
Yeah.
It's called Gibbs free energy change.
Okay, so is delta G a given that goes with the equation, or do you have to calculate that?
It depends on the problem.
Okay.
See, in this example, delta G was given to you, you will ask a question.
Right.
In this example, we are not giving you delta G, we give you delta H and delta S. Then you can calculate delta G from this formula.
Right.
And
And
then you,
for the first one and the second one, the one in black and the one in red, are you able, are all three of these actually, are they all spontaneous, or are they different? Some are like one's spontaneous, one is.
you look at the delta G value. Do you see this is positive?
Yes. So does that make it spontaneous?
No, we said if delta G is negative, reaction is spontaneous. Delta G is positive, reaction is non-spontaneous.
Okay. And what if, go ahead.
And what if the reaction is delta G is 0? If it is 0, reaction is an equilibrium reaction.
Gotcha.
All of those are, let's say, go back here. Previous slide.
Oh, I'm sorry. Yeah, I didn't realize what I was writing down when I did that.
It's fine. Fine.